Do memories have mass? I mean, memories feel so intangible, like whispers in your mind, a first kiss, the smell of rain on hot pavement, your grandma's laugh. They're there 1 second, gone the next if you don't hold on. Weightless, ethereal. But what if they're not? What if every single thing you've ever remembered is adding actual weight to your head right now? Let's start simple. What even is a memory? It's not floating in some ghost cloud inside your skull. Memories are physical changes in your brain. Neurons fire, synapses strengthen, proteins shift around, new connections form, like tiny bridges being built across electrical gaps. When you learn something new, your brain literally rewires itself. Dendrites sprout, molecules lock into place. It's all matter, atoms, and atoms have mass. But does that mean the memory itself has mass? Hold on. Everyday intuition says no, ideas don't weigh anything. You can carry a library of books in your head without your backpack getting heavier. But zoom out a bit. Einstein's E equals mc squared tells us mass and energy are two sides of the same coin. Change the energy state of something and you've changed its mass, even if it's by a whisper. A memory isn't just static stuff, it's a stable pattern of energy in your neural network, like a sculpture carved from brain tissue, holding its shape against entropy. So, does forming that pattern cost mass or add it? There's a wild experiment from the 1960s that hints yes. Researchers trained planaria, those little flatworms, to navigate a maze. Fed them some junk food laced with the worms' own ground-up brains, a technique called memory transfer. But that's a tangent for later. The key? The trained worms' brains weren't just smarter, they weighed more. Slightly. Enough to measure. Follow-up studies with rats running mazes showed the same. Learning pumped up their brains with extra RNA and proteins. A 10% maze master? Brain mass up by about 0.1%. Not nothing. Scale that up to you. The average human brain clocks in at 1.4 kilograms, packed with 86 billion neurons and something like a quadrillion 10 to the 15th synapses. Each memory isn't one synapse. It's a network, maybe thousands overlapping. But let's ballpark. Suppose strengthening a single synapse adds just one extra protein molecule. That's about 10 to the minus 20 grams. Tiny. For a vivid memory, say 10,000 synapses beefed up, that's 10 to the minus 16 grams. A million memories? You're looking at a microgram or so total. That's the mass of a single bacterium, or the weight your brain gains from eating 1 grain of rice. But here's the escalator. Lifetime memories? You've got decades of them. Childhood flashes, song lyrics, every face you've recognized. Estimates put the total info storage capacity of a human brain at around 2.5 petabytes, enough for 300 years of HD video. If we convert that to physical heft via energy differences, physicist Melvin Vopson proposed something provocative recently. Using Landauer's principle, the thermodynamics of information, he calculated the mass equivalent of 1 bit of data. It's absurdly small, about 10 to the minus 38 grams per bit. For your whole brain's memories, still less than an electron. But it's not zero. Information has a shadow mass. Now, tangent time, because this gets weirder when we think digital. Your phone stores memories too. Photos, texts, cat videos. Does that data have mass? Absolutely. A hard drive's atoms are arranged just so to hold bits as magnetic domains. Flip a bit from 0 to 1, and you've nudged electrons into new orbits. E equals mc squared again. That's a measurable mass shift, down to 10 to the negative 25 grams per bit. Google did the math. Storing all human knowledge digitally adds about 70 grams to the world's servers. 70 grams of pure memory mass, humming away in data centers. If we ever upload our minds, like full brain emulation, that digital you would weigh more than the meat version. By how much? Depends on the hardware, but enough to notice if you stacked 1 billion minds. But wait, does forgetting erase that mass? Not really. Memories don't vanish like deleted files. They fade, reorganize. Synapses weaken, proteins degrade, but the atoms stick around, recycled into new patterns. Your brain is a closed system, mass conserved. Learning might bloat it temporarily, Newborn brains grow fast, packing in basics, but adulthood is pruning. Old folks' brains shrink a bit, sure, but that's not lost memories weighing less, it's atrophy, disease, entropy winning. Zoom out further. Imagine we could weigh a brain before and after a lifetime. Fresh cadaver, 1.4 kilograms. Sage elder, maybe 1.3. Part of that's fluid loss, cell death. But buried in there, the net mass of experience. Every grudge nursed, every skill honed, every love etched, physical residue. And collectively, 7 billion brains, each carrying terabytes of human story. That's grams? Kilograms? Of global memory mass. Not enough to tip a scale against a mountain, but real, measurable if we had the tools. So, do memories have mass? Technically, yes. A fleeting, fundamental yes. But the real mind bender isn't the number. It's this. Your thoughts, the stuff that makes you, you, aren't separate from the universe's heft. They're woven into it. Every recall tugs on atoms that tugged on stars billions of years ago. Massless illusions? Nah. You're a walking archive of matter rearranged by meaning. Next time you remember something painful or beautiful, feel your head. It's heavier than you think. And lighter too, because without that weight, who'd you be?